What is average? This is Jason Engel, your professor for Math 96, and we're going to be looking at lesson 2.9, which is a large section, so I'm doing it in 3 parts. Part 1 of 3, what is average? The objectives are that the numerical data can be summarized using measures of central tendency. Now we have 3 statistics, mean, median, and mode, and they provide a different snapshot of the data. And third, we want to understand that conclusions derived from statistical summaries are subject to error. Pictured above is a long line of people waiting to buy tickets for a concert. So each black dot is a person standing in line. The 0 marks the beginning of the line, and the 100 marks the end of the line. This is a line that's 100 feet long. In some sections of the line, people are grouped together very closely, while in other sections of the line, people are spread out. How would you describe where the center of the line is? How would you describe it? There's several logical answers to that question. I think some might say that 50 feet, since the line is 100 feet long, that 50 feet would mark the middle of the line, and that would be reasonable. But others might argue, no, it would be more meaningful to pick the person that's the middle person of the line. That is to say, the person that separates an equal number in front of them from an equal number behind them in the line. And since most of the people appear to be clustered closer to the beginning of the line, then I suppose that middle person would be somewhere between 40 and 50 feet from the beginning of the line. And yet a third way to describe the middle would be to just simply locate the clusters where most of the people are. And so one might go so far as to say that 10 feet from the beginning of the line is the middle line because that's where most of the people are clustered. There's a certain logic to that too. And the answer that you would choose would depend on what you needed the center for. So mean, median, and mode. That's what we call these. The mean is the one that you're probably familiar with already. If you have 5 numbers, you very simply add them up and divide by the number that's there. In this case, the 5 numbers add up to 140, and since there's 5 numbers, you divide and get 28. If there was a 6th number, then it's pretty much the same thing. You add up the 6 numbers and then divide by 6 instead of 5 because there's 6 numbers. Now notice that including a number of 1,000, which is relatively large compared to the rest, had a pretty dramatic effect on the mean. The mean in this case is 190, which effectively is separating the one number that's bigger than it from the 5 numbers that are all smaller than it. The median, on the other hand, well, in a sense, it's simpler to compute. You just have to put the numbers in order first. In order, we can clearly see that 23, the number 23 separates the 2 smallest numbers in the list from the 2 largest numbers in the list, so 23 is the median. In this example, there isn't a single middle number. In fact, there's 2 middle numbers, 23 and 36, so the median is the average of those 2. 29.5 separates the 3 smallest numbers from the 3 largest numbers. And the mode, again, it's easier to see if they're in order. Since 18 appears twice, and that's more frequently than any of the other numbers, we'd say that 18 is the mode. Here's an entirely different set of numbers. Put those in order. We can see that the 7 appears 3 times, the 8 appears twice, and the 10 appears 3 times. So we'd say that both 7 and 10 are the modes. However, if you have a list such as 4, 5, 7, 8, 9, 10, this one has no mode because each of the numbers shows up an equal amount.